Hello friends, today we are going to discuss about the ANOVA. ANOVA means analysis of variance. So we know that if we have two or less than two samples, then in statistical technique we use z-test or t-test. But what if we have more than two samples, means three sample, four samples, that time how we can find out the mean, variance, standard deviation? So when we have more than two samples, that time ANOVA come into the picture. Let's see that. The analysis of variance means ANOVA is used to determine whether there is any statistical significance difference between the means of three or more independent or unrelated groups. So here it is mentioned that this technique, ANOVA technique, is used to determine whether there is any statistical significant difference between the means of three or more independent or unrelated groups. Let's try to understand this. So from this figure, you can easily understand that these three samples x1, x2 and x3, all these three samples are coming from the same population. So what it shows that the mean of this x1, the mean of x2 and the mean of x3 is very much nearer to the mean of the population. Means if the samples are coming from the same population, it is expected that the mean of the samples are very much nearer to the main population. From this figure, what we can conclude? We can say that this x1 bar and x2 bar are from the same population, whereas this x3 bar means this sample is not belonging this population, means this x3 sample is from some other population. So we can say that the mean of green sample does not belong to the major population, means this is not belonging to this population. From this figure, what we can say? We can say that x1 bar is from the main population, whereas x2 bar and x3 bar is not from this population, main population, because the mean of this x3 bar and x2 bar is far away from the mean of the population, whereas x1 bar mean is very much nearer to the population. Here what we can say? All these three samples are from the same population. But here important thing is, please note, here we are not asking that the mean of this samples x3, x2 and x1 is exactly similar to the mean of the population. We are saying that the means of these samples must be near mean of the population. So from this, the use of the ANOVA is clear, that ANOVA is used to measure the difference between the means of three or more than three independent groups. Let's move ahead. So this ANOVA technique is developed by R.A. Fisher in 1920. This test is also known as F-test, because this test is based on the F distribution, which is invented by G.W. Snedeker. This technique compares the mean between the groups and determine whether any of these means are statistically significantly different from each other or not. It determines whether all groups are taken from common population or not. Yes, we had discussed all these points in the previous slides. So how we can find out the ANOVA? ANOVA is the ratio between mean sum square between sample. and mean sum of square within sample. So we know that in F distribution is the ratio of variance. Variance 1 upon variance 2. ANOVA is the ratio of mean sum square between sample upon mean sum square within sample. Now here it is important to understand that between sample and within sample, the variation among the observation of each specific group is called its internal variation, and the totality of the internal variation is called a variability within group. The totality of variation from one group to another, that is variation due to group, is called variability between the groups. Here we have three samples: group 1 sample, group 2 sample and group 3 sample. If I compare these two groups, then I will say that I am comparing the variance between these two groups. So here I am going to use the word between. If I am doing the comparison between the samples, whereas if I am finding out the variance in a same group, that time I will say that I am finding variance within a group. So within word is used for the same group or same sample, whereas between word is used to compare two samples. I hope this is clear. So we can understand that ANOVA is the difference between the means, between the variance and within variance. So between the variance means between the samples, and within a variance means in a sample. So this is the F distribution table. So as I told that ANOVA is using the F distribution. So here we have two tables for F distribution. First one is 1% of level of significance and another one is 5% level of significance. Here we are going to find out the values from the degree of freedom only. For example, if I have a first degree of freedom or V, let's say 4, and second degree of freedom which is V2, let's say 5, then the level of significance considering 1%, the value of F will be 4. I am going to find out here because it is a first degree of freedom. So 4 and 5 is the second degree of freedom. So I am going to take the intersection of both, and the value is F value is 11.39. This way we find out the value of F. Similarly, we have the another table with the 5% level of significance. Here also we have 2 degree of freedom. First degree of freedom we have to look into the rows, and second degree of freedom we have to look into the columns. Here also if I want to find out the F distribution for 5 and 9 degree of freedom, it means that it shows that 5 is the first degree of freedom and 9 is the second degree of freedom. So here I am going to find out V1 at 5 and V2 at 9, and I am going to take the intersection. So the value is 3.48 at 5% level of significance. Let's move ahead. So ANOVA is basically divided into two types: one-way ANOVA and two-way ANOVA. In one-way ANOVA, we have one independent variable, one independent variable, and in two-way ANOVA, we have two independent variable. So what is the interpretation of ANOVA? So here also like Z test and T test, before solving the question, we are going to assume the hypothesis. So here also we are going to assume null hypothesis and alternate hypothesis. So in null hypothesis, what we are going to assume? We are going to assume that the mean of all the groups are same. Means there is no significant difference between the means of all the groups. All groups are same. Whereas in alternate hypothesis, we are going to assume the contradiction of this. It means there are at least two group means that are statistically significantly different from each other. Or in simple words, we can say that in alternate hypothesis that mu1 is not equal to mu2 is not equal to mu3 and so on. Then before reaching to the conclusion, we have to calculate f value. So calculated f value we have to find out, and from the table also we have to find out the f value, and we are going to compare f calculated and f tabulated, and from that we are going to accept or reject our hypothesis. So here also, like Z test and T test, the fundamental is same, that in a normal distribution, if let's say that this is f tabulated value, then we know that this region is called as acceptance region, acceptance region, and this region is called as rejection region or rejection or LOS. Here we are going to consider the LOS. Now, if calculated value is smaller than f tabulated, let's say f calculated value is smaller than f tabulated value, it means that the calculated value of f lies in this region. So the value of f is in the acceptance region. So in that case, we are going to accept null hypothesis, accept null hypothesis and reject alternate hypothesis. If the value of f calculated lies in this region, what it means? If f calculated value is greater than f tabulated value, then what it means? It means that we have to reject null hypothesis and accept alternate hypothesis. I hope this is clear. Now these are the few steps with which we are going to solve the ANOVA problems. So in that, first we have to find out correlation factor, then we have to find out total sum of square, then we are going to find out between sum of square, within sum of square, then we are going to prepare the ANOVA table, we are going to find out degree of freedoms, then MSS, which is mean sum square, and F ratio we are going to find out, and then in last we are going to interpret the result. I know that from this it will be very difficult to understand, but immediately we are going to solve one question. With that question, very easily you can understand this ANOVA technique. Before starting our problem, I just wanted to show you this summary table. So we are going to create this summary table at this 5. So this fifth point is preparation of analysis of variation table. Variation table means this table we are going to solve. So here we are going to consider these values, and here with this f value we are going to conclude. So let's try to solve the problem. So in the question, what is given? The 3 samples below have been obtained from the normal population with equal variance. Test the hypothesis at 5% level of significance that the population means are equal. Okay, Step 1, null hypothesis. So what will be our null hypothesis? We are going to accept that the population means are equal. These are the three groups: first group, second group, and third group. So we are accepting that the mean of first group is equal to mean of second group and equal to mean of third group. Step 2, in alternate hypothesis, we are going to say that mu1 is not equal to mu2 is not equal to mu3. Step 3, in step 3, what we are going to do, we are going to find out the summation values. So let me first put down these values. These are given values. Now, from these steps, here the first step is find out the correction factor. And the correction factor is denoted by C, and the formula of that correction factor is T square by N. So here what is T? T is the grand total. How we can find out this grand total? Grand total means the addition of all these things. So 8 plus 4, 10 plus 7 plus 14 plus 11. This is equal to 50. Then 7 plus 5 plus 10 plus 9 plus 9. This is equal to 40. Then 12 plus 9 plus 13 plus 12 plus 14. This is equal to 60. So here the grand total is 50 plus 40 plus 60, which is equal to 150. And N here is total number of samples. So here total elements of the sample is these 5 plus these 5 plus this 5. So total value of N is 15. So here our correction factor is 150 square upon 15, which is 1500. Let's move to the step 2. In step 2, we are going to find out total sum of square, which is SST. Now what is this SST? The formula for this SST is equal to summation of x1 square plus summation of x2 square plus summation of x3 square minus correction factor, which is T square by N. So summation of x1 square, x2 square and x3 square means we have to do the square of each element and we have to add that. So let's do this. So the square of 8 is 64, 10, 100, 49, 196, 121. And the addition of all these three is, addition of this is 530. Similarly here 49, 25, 100, 81, 81, and the addition is 336. And here 144, 81, 169, 144 and 196. So this is equal to 734. So here summation of x1 square means 530 summation of x2 square means 336 plus summation of x3 square means 734 minus correction factor which is 1500 we just had calculated. So the total SST is 100. Now let's find out the degree of freedom for this SST. So the degree of freedom for SST is equal to capital N minus 1. So capital N we know that 15, total elements of all the samples, so this is 15 minus 1. So degree of freedom is 14 here. Next step, between sum of square, between sum of square, this is also called as column sum of square, so that's why SSC, C is for column. So we know that between sum of column means here now we are comparing two samples, we are comparing the group of samples between the samples. So the formula for this is SSC is equal to summation of x1 square upon n1 plus summation of x2 square upon n2 plus summation of x3 square upon n3 minus t square by n. So let's put the value. So this x1 square, x2 square and x3 square means 50 square plus 40 square plus 60 square. So 50 square plus 40 square plus 60 square, and here n1, n2 and n3 are same, which is 5. So n1 means the number of elements in first sample, n2 means number of element in the second sample, and n3 is the number of element for third sample. So in each sample we have 5 elements, so that's why in the denominator the term is 5, the value is 5 minus this 1500 correction factor. So the value we will get here is 40. So SSC is equal to 40, and we have to find out degree of freedom for this SSC also. So here degree of freedom is C minus 1. C is for column. So here we have 3 columns, 3 samples. So 3 minus 1, this is equal to 2. Next step, within sum of square, within sum of square, this is also called as within sum of error. So that's why this is SSE. E is for error. So this SSE is SST minus SSC. So how we can get this? From this table. So here between, within and total. So we have calculated SST, this is SST. We have calculated SSB, and here SSW or SSE we can get by subtracting SST minus SSB. We will get the value. I know that SST is 100, SSC is 40, we just had calculated. So SSE is 60. Let's try to find out this in table. Let's plot this in table. So source of variation. I'm just trying to create the same table which we just have seen. Then sum of square, degree of freedom, mean square, and F ratio. So here this source of variation is between the samples, within the sample, and the total. So between means SSC, this is SSE, and this is SST. So SSC we have calculated, which is 40. SST is 100. So 100 minus 40 is equal to 60. We have calculated this, and by subtracting SSC from SST, we can get the value of SSE. Same for degree of freedom. Degree of freedom for SSC is C minus 1, which we have calculated. 3 columns we had, so 3 minus 1, this is equal to 2. For total degree of freedom, we have calculated n minus 1. So n means the total sample. So we have 15 sample, 15 minus 1. So this is equal to 14. Now to find out degree of freedom for this, what we can do? We can subtract 14 minus 2. So the value will be 12. N minus C, that is equal to 15 minus 3, that is equal to 12. Then mean square. So this is mean square between the samples or between the columns. So I will write it here, MSC. C is for column, mean square of column. So the value for this is SSC upon C minus 1, means sum of square upon degree of freedom. So this value is 40 by 2, that is equal to 20. And MSE is equal to SSE upon degree of freedom. So 60 divided by 12, that is equal to 5. Now the next important step for the F ratio. So to calculate the F ratio or the calculated value of F, we can find out like this. So F is equal to, now we are going to see that which value is the maximum value between MSC and MSE. So here MSC is 20 and MSE is 5. So the larger value is 20. So the larger value will come into the numerator. So MSC is in the numerator, and in the denominator the smaller value. So MSE. Also here, while writing the degree of freedom, the numerator degree of freedom we are going to write it first. So the degree of freedom for this numerator value, means for SSC, is 2. So first we are going to write 2 and then we are going to write 12. If we calculate this, so 20 divided by 5, that is equal to 4. So the F calculated value is 4. Now we have to find out the value of F in table. So in the table we are going to find out the value of f at the value 2, 12. This is very important. 2 is for the numerator, the degree of freedom from the numerator, and 12 is the degree of freedom from the denominator. So 2 upon 12 at 5% level of significance. So let's see this in the table. So 2 and 12. So the first value is this 2 and 12 is here. So the intersection of 2 and 12 is 3.88. So the F tabulated value is 3.88. So here we can say that F calculated is greater than F tabulated, that is 4 is greater than 3.88. What it means? Reject null hypothesis and accept alternate hypothesis. That is, the means of all the samples are not equal. Mean of samples are not equal. I hope you understand this, ANOVA. Thank you.